I guess I'll start with the ancient technology, which is plating. That's been around for some time. And basically, this is where you take your sample, you add some sort of growth medium, right? BPW,
Yep.
tryptic soy broth, TSB,
Yeah.
you know.
Classic.
Yeah, classic growth mediums. Basically, you put that in with your sample, typically a 1 gram sample. It really just depends on what state you're in. Other industries use a lot larger sample sizes, something
Hmm.
like, anywhere from 5 to 25 grams or even upwards of 50 grams. It really just depends on what you're testing, right? But since
Right.
cannabis is a very precious commodity, people don't want to give up their, ultra high quality stuff more than a gram. So that's typically what we see out there in the marketplace. But basically, you're homogenizing your sample, usually with a stomacher or with, by hand massaging. And then you're taking that and you're taking a small subsample of that and then plating it. So basically placing that and inoculating the plate and then, streaking it or, basically spreading it uniformly across the plate's surface. And then you're incubating that depending on what you're testing for. You may incubate it for, from 25 to 27 C is what's typically done for Aspergillus, up 5 to 7 days,
Hmm.
up to 7 days type of thing. But it's going to differ for every different microorganism that you're testing for. And then you're basically taking whatever you diluted it at. So you're counting the colonies on the plate and then multiplying it by that dilution factor. And now you have a colony forming unit per gram readout. And that is typically your standard readout that you see in just about everywhere. I mean, while qPCR is very commonly accepted now in the cannabis industry, when it comes to things like total count tests, you do have to convert that CQ value or cycle of quantitation, which I'll get into a bit more later, but you have to convert that value into something that is acceptable for regulators, which is that CFU per gram.
Right.
Now, plating is good because it is only enumerating what is actually viable within the sample, right? And so a lot of people aren't concerned about what's dead in a sample or what was left over. And so that is an advantage of plating. A disadvantage of plating is that some of these things don't grow very well in culture. It depends, again, what type of mediums you're using, what types of broths you're using. There's a number of factors that can contribute to how well something cultures on a plate. So I would say those are kind of like the high points of plating and the potential drawbacks of it. But then there's molecular methods like qPCR. qPCR, right? So this is quantitative polymerase chain reaction. So for those of your listeners that are familiar with polymerase chain reaction, now this is just monitoring that reaction in real time using different fluorophores. And so you're typically a qPCR run is 40 cycles. You are looking at, how quickly does it amplify? So, and then at the point at which it crosses a threshold, so you set that threshold to remove any background, the point at which your qPCR signal crosses that threshold is what we call a cycle of quantitation. So that is the point at which it is crossing that threshold line and the actual cycle number. So basically, the earlier of a CQ you have, that means that the greater presence of your target there is because it's amplifying quicker, whereas if it's amplifying later, then that means you had less of your target. So that would be a higher CQ value, right? And so I guess the disadvantage with qPCR is that you aren't just selectively amplifying what is alive. You are getting everything because DNA is DNA. So you're going to amplify everything. And some people push back and say, well, hey, isn't that to our detriment? If you have a bunch of dead stuff on there, well, why am I failing for dead stuff? That just doesn't make sense. Well, a couple things there, right? So in the context of things like Aspergillus or other mycotoxin producing fungi, if there's a bunch of that left over, well, that could be indicative that you have mycotoxins in your sample. Now, of course, many states have opted for mycotoxin testing, things like aflatoxins and ochratoxin. And so that checks that box, right? But still, it's good to know. And a lot of people have this misconception that because you're amplifying all of these things, right? That you're going to fail more as a result. But actually, we find that it's, at least in my experience, it was the opposite. And I think the reasoning for that is, and I guess this is another drawback of plating that I forgot to mention, and this is a perfect tie-in. Well, there's a lack of selectivity. So typically when you're plating something, you're using selective growth media. that are supposed to foster the growth of a particular class of microbial contaminant. Now, there's growth mediums. There's also antibiotics that are used for selection in this case. And as we all know, antibiotics are, microorganisms are becoming more and more resistant to these things. And just because you select for it based on an antibiotic or some sort of growth medium doesn't necessarily mean that off-target organism growth isn't going to happen. So what the publications that medicinal genomics have done have showed is that there is a significant amount of off-target growth happening, especially in the context of total yeast and mold plates. And depending on what state you're in, typically the limits are around 10,000 CFUs per gram. But if you're getting, off-target growth, you're counting dots that are actually not yeasts or molds. You're counting oftentimes bacteria. And so this, of course, leads to inflated counts, more failures. And so people have this aversion to moving toward qPCR because they think that's going to happen, more frequently. Yeah. But really, it's the opposite because you're using targeted primers. You are selectively amplifying only for the class of organisms that you're looking for. You don't have this potential for off-target growth in that case.